step to measure the coin diameter. I'll start with the sample image created earlier. This is the €1 coin. Looking under Machine Vision, and I want to find Max Clamp. Measures the maximum distance separating object edges. Seeing a complaint here, it's essentially saying it wants a gray level image instead of a color image. I'll come back here to Color Operations, look for Color Plane Extraction. And specifically, I want the luminance plane, and this will be the gray level image. Note that when you select the color plane extraction of the current step, it looks gray. If you go back one step, it looks like color again. This way you can see the output of each step. Let's come back to Max Clamp. I need to get the region of interest to include where all of the sample images are located. Here we see the start point and the end point that has been detected. And scrolling over here a little bit, we see the distance is being reported in millimeters. Again, that's a result of the camera calibration step done earlier. Now, if you watch that number in the red box, you can see the measured diameter for each one of these coins when you make it the active image. Use the overlay graphics to confirm that the measurement is being done properly for each one of your representative images. All right, this looks pretty good. I'll draw your attention to this configuration option here. If you set it to a very narrow angle, such as 1, then it constrains the search direction along the horizontal. If you want to make it more flexible and search for the maximum value at all possible angles, just set that to 180 degrees. Let me run one more time through the sample images. It's always a good idea to make sure that you check all of your representative images each time you make a significant change to your processing script. You want to make sure that you haven't broken anything in the process. All right, I'll finish up by saving this script away to a file. I'll put it in my usual location. The Vision Assistant scripts have the file suffix VASCR, and I'll call mine coin diameter. Whether or not the coin is smaller or larger than 23 millimeters. So the measurement is based on this diameter indicator right there. Let's come back to the block diagram. Look for the myRIO subpalette, looking for onboard devices and then LEDs. I'm going to disable LED 1 and 2, making use of just 0 and 3. Open up a little room inside the processing loop. We'll place that Express VI right there. Next, I'm looking for the comparison subpalette. We'll pull out the greater than, and I'll be comparing the measured diameter against the threshold value of 23 millimeters. Use a constant for that purpose. Now the Boolean output of this comparison will be true when the diameter exceeds 23, and that will activate LED 0. I'm going to use a not function here, and that will cause the other LED to be active when LED 0 is not active. So one or the other is going to be active at all times. I'm also going to create some front panel indicators just to reflect the state of the two external LEDs that you'd be able to see on your own myRIO. And I'll simply call those the same names, LED 0 and LED 3. And again, these LEDs are more cosmetic in nature. They allow me to show you the state of the actual myRIO LEDs. Let's do a new compile and then deploy on the myRIO. And let's see, the Euro coin, a little bit less than 23, so the LED 0 is off and LED 3 is on. There's a dime coming in at 17 millimeters. Let's try a larger coin. All right, that's activating LED 0 now. And let's just try one more coin. Almost 30 millimeters. All right, this concludes the coin caliper project, and if you've been following along through all of the steps 1 through 7, congratulations, you've now finished the design and development of your first machine vision application.